All right, has anyone heard of the phrase jumping the shark? I think I'm jumping the shark with math videos. Let's talk about doubling time, okay? So the doubling time of a growing quantity is how long it takes to double. Okay, doubling time means time to double. Okay, not crazy, right? And then half-life is a little bit more confusing. We won't talk about that very much. That's just the time it takes to be halved. So let's see, how do we use this stuff? Okay, with example 2. If we invest money at 8% compounded quarterly, how long will it take our money to double? So remember that our compound interest formula is that the amount after t years is the principal times 1 plus r over n. I think we may have used the letter k to the kt. All right. If this is the case, well, P is how much we started investing. We don't know that yet. Okay. R is the interest rate as a decimal. We do know that, 0.08. And K, we'll talk more about compound interest in chapter 6. But here's the formula that we can use for now. K is how many times it compounds in a year. So if it's compounding every quarter, it's 4 times a year. There are 4 quarters in a year. Happens 4 times. All right. And then T, we also don't know. A, we also don't know. See, you're looking at this and say, okay, Jason, what the heck is going on? We don't know anything. How are we gonna do anything? Well, we know the money's doubling. So whatever we started with, we know that after some number of time, the amount that we have is double what we started with. Okay? So let's see what happens if this is all true. If the amount is double what we started with, we want to know when the starting value times this whole thing, r is 0.08, divided by k, is 4, raised to the 4 times t. We want to solve this for t. We want to know when, how long. That's a time thing. It's asking for t here. All right? Look what happens. We want to get the exponential part by itself. We want this part to be by itself. So what are we going to do? We're going to divide both sides by p. And when we divide both sides by p, what happens? The p's cancel on that side. The p's cancel on that side. It's just when it's 2 equal to this whole thing. Oh, p didn't matter. Doesn't matter whether we started from 10 or 20. We're just finding how long it takes to double. Because the time it takes to double actually doesn't matter how much you started with. This is exponential growth. It grows by 1% every year, so it doesn't actually matter what we started with at all. Ah, okay. Let's simplify this inside. Okay. That's going to be, here, let's go off to the side. What is this inside? 1 plus 8%. So we're growing by 8% in a year, but every quarter we get 1/4 of that. So every quarter, that's going to be 2%. Okay. So every quarter we multiply by 1.02. Ah, okay. This is 1.02 in here. How do we solve this? We have an isolated exponential function. We undo that with a logarithm. Let's take the logarithm of both sides. Any logarithm. So the left-hand side is the natural log of 2. The right-hand side, remember when we take the logarithm, that exponent comes out in front. That was one of our properties of logarithms, the exponential property. So this is 4t times the natural log of 1.02. We're almost there. We need the t by itself. If we divide both sides by 4, the 4s are going to cancel. And if we divide both sides by the natural log of 1.02, this cancels too. And the t is all that's left on that right-hand side. What do we get? T is going to be that, whatever that is. The natural log of 2. And remember, we can't actually simplify this at all. We could approximate with a calculator, but there's no properties of natural logs that let this simplify. So, t, let's use a calculator. ln 2 over 4 ln of 1.02. About 8.75. Oh, how long is it going to take? How many years? Well, about 8.75 years, right? Remember, t is in years here. About 8.75 years. Or 8 3/4. 8 years and 3/4 would be a better answer. But they're both fine. Remember, it's compounding every quarter. All right? So that's what we got here. Okay, and that's how we use doubling time. Try this one now. Try this one on for size. Try to pause the video, see if you can get it. I'll do an extra example here. So what we got about doubling time. Let's see if you can get it. Use of a new social networking website has been growing exponentially, with the number of new members doubling every 5 months. If the site currently has 120K users and this trend continues, how many will it have after a year? All right, let's look at it. Well, we know exponential growth looks like some y is our starting value times some b value raised to x. So now what do we got here? Well, we know our starting value is 120K. Let's let y is users in 100,000s. I don't want to write that many zeros. 120,000s. Okay, what's our growth rate? We know we're doubling every 5 months. But that doesn't exactly tell us our growth rate. And should x be month or years? It's your choice. Okay, let's have x be months. That way we don't have to do fractions. So I know that in 5 months we're going to be doubled, right? So we know when x is equal to 5, y will be 240. I know we're doubling every 5 months. We can solve for b, right? Let's plug that in. When y is 240, x is 5, we can find out what b are. BR? We can find out what b is. This is another, not an exponential equation anymore, actually. This is a polynomial equation. But the idea is very similar. We get the variable by itself. Divide both sides by 120. The left-hand side is just 2. That's not a coincidence, my friends. Anytime you're finding a b value from doubling time, you're going to get a 2 over here. So now, you could technically log both sides, but this is not an exponential equation. Remember, there's a big difference between these two things. Exponential equation, quadratic. So we actually have a polynomial over here. And the way to solve this is to take the 5th root of both sides. So b is actually the 5th root of 2, which is the same as an exponent of 1/5. It's your preference. Either one of these mean the same thing. Your preference, which one you want to use. Let's find our b value. What is the 5th root of 2? About 1.1487. Make sure to include at least 4 or 5 significant figures here. So now that we know the b value, we now have our function. Once we have our function, we can now use that to find out how many users we're going to have in a year. So we know y, we start with 120. And we know we're growing by about 15% every month. Remember, x is in months. All right. So how many are we going to have in a year? A year is x equals 12. Let's use the function. That's a nice thing about functions. 1.1487 raised to the 12th power. Let's go. All right, 120 times 1 point, I already forgot, 1487. Raised to the 12th power is about 633.375. Jason, why are you using decimal places if we're talking about how many users there are? Well, remember the users is in hundreds of thousands. Okay, so we do need to include units in our answer here. This is not our final answer. Okay, we're going to say that 633,375 users after a year. And that's going to be our answer. Okay, and that's what we've got here. So hopefully this gives you some more practice with these. Let me know if you have any questions, and have a good rest of your day.